Agriculture uses an enormous amount of resources. It takes a lot of water and energy to grow our food. 85% of the global water resource consumption is used for irrigation, and 1/3 of greenhouse gas emissions are attributed to agriculture. At the same time, demand for food is only growing. The global population, currently at 7.5 billion, is estimated to reach 9.8 billion by 2050. We will need to nearly double our current food production to meet that demand. We will also need to improve access to food, reduce food waste, and address inequities related to food deserts. Food is complicated, and an approach to a dynamic and sustainable food system is multifaceted. Let's focus on the future production and resource management side of the equation. Looking at the water issue alone, with the current agricultural methods, there will be nowhere near enough water to grow the needed level of food production by 2050. And we are all aware of the high cost of fossil fuels on our wallets and on the environment. If the status quo remains, we will likely be looking at food shortages, which in turn could cause social unrest and potential economic collapse. Agriculture has always adapted to meet the dynamic needs of a changing society. Innovations in technology have driven incredible progress over time, from tractors and pest management to breeding and genomics. Most growers are accustomed to exploring new methods of addressing emerging challenges in agriculture and continue to look for ways to mitigate risks brought on by a changing climate. Water, energy, and agriculture are the bedrock of modern civilization. And while many technologies have advanced these components separately, few have aimed to address all three components at once. It is time to step back and reimagine their relationship. Enter agrivoltaics. This new technology promises to improve food production and reduce water use, while also creating energy and additional revenue. The solar panels are placed on the same land where crops are grown, allowing growers to harvest the power of the sun twice. A recent OSU study estimates that converting just 1% of American farmland to agrivoltaics could meet our national renewable energy targets and save water and create a sustainable long-term food system. It will also create new revenue opportunities for family farms which are currently facing increased economic challenges, with a 23% increase in bankruptcy filings over the past year. The solar panels also help plants grow more efficiently by needing less water. See, plants have an upper limit on how much sun they can actually use. It's called the light saturation point. Beyond that point, any additional sun doesn't increase photosynthesis. It doesn't help the plant grow. It simply increases the plant's water demand. It makes the plants sweat, and it makes them more thirsty. Solar panels can be positioned to allow plants just the right amount of sunlight. And then the excess sunlight can be harvested for electricity and produce more electricity than they would without crops below them. The plants help keep solar panels cool, which makes them more productive. Our studies have shown that panels positioned above plants produce up to 10% more electricity. Agrivoltaics is a symbiotic relationship where both the solar panels and the crops benefit because they help each other perform better. The electricity can be used to run the farm with electric tractors and equipment, and to power precision ag technology that helps further reduce water usage. Surplus energy can be stored in battery banks or sent to the grid for consumer use. It's a win-win-win relationship between the three most foundational elements of modern life: food, water, and energy. We are creating a model of the sustainable farming system at OSU's North Willamette Research and Extension Center in Aurora, Oregon. The 5-acre model is expected to be fully functional by fall 2021. Our current projection estimates that converting 1% of American farmland to agrivoltaics would cost an initial investment of around 1% of the federal budget and would be paid for in energy savings within 14 years. More importantly, it would help meet future demand by growing more food and using less water, while also creating sustainable energy at the same time. This type of systems thinking approach is the only way to solve the intertwined issues of long-term sustainable farming, energy production, and water conservation. And it's how the College of Agricultural Sciences at Oregon State University is working to make tomorrow better.